Hello everyone, I am Teacher Dennis, your Math Explorer teacher. Are you all excited to learn more all about mathematics for today? If yes, then let us explore more all about mathematics lessons. So for today, we'll be dealing with understanding this double integral. But did you know, class, during the first time that I browsed the lesson regarding double integral, I find lots of difficulties and challenges in dealing with this. And now, I am trying to cope up little by little and understanding this double integral. And for now, let us discuss it simpler. So when we say double integrals are a way to integrate over a two-dimensional area. Double integrals allows us to compare the volume under a surface. Furthermore, given a two variable functions f, coordinates of x and y, you can find the volume between the distance in the graph and the rectangular region or the xy plane by taking an integral of an integral. Did you know that double integral is in the form double integral of function f, coordinates of x and y, with respect to x from a to b, and with respect to y from c to d? Did you get it, class? If yes, let us proceed to our next discussion. Did you know that most of the students and most of the people are asking if what is the importance of double integral? Some of them think of where does this double integrals being applied. So today, let us discover where does this double integrals being applied. First, double integrals are applied in finding the area of a region bounded by curves of functions. Second, finding the volume of an elliptic paraboloid. Third, finding the average value of a function of two variables over a rectangular region. Fourth, finding the volume under the surface. And lastly, finding two choices in direction. Let us discover more about double integral by studying and exploring more examples. Let's go! Here's now an example for the problem regarding the double integral. So today, I'll be showing to you how to compute for the integral. And here is now our problem. So our problem is we are going to compute the integral for this. So the double integral dxy squared d of a, where d is the rectangle defined by x, which is greater than or equal to 0 and less than or equal to 2. While our y is greater than or equal to 0 and less than or equal to 1. Let us base on the picture below. So as what we could see, here is our graph. So our graph looks like here. It is a rectangle wherein the values of our x is 2 and the value for our y is 1. Here is our x and here is our y. So for the values of our x's, or for our x, it is with a limit of 2 and 0, where our x is greater than or equal to 0 and less than or equal to 2. While for our y, it is with a limit of 1 and 0, wherein our values for y is greater than or equal to 0 and less than or equal to 1. So we first integrate with respect to x here, inside the parenthesis. Similar to the procedure with partial derivatives, we must treat y as a constant. So, back with this equation, or xy squared, or the double integral of xy squared with respect to our x from 0 to 2. And with respect to y from 0 to 1. So, we are going to first calculate with respect to x inside our parenthesis. During this integration step, since for any constant c, the integral of c of x is equal to cx squared all over 2. So now, we are going to calculate. So from here, the double integral with respect to x, x squared all over 2, y squared from 0 to 2. With respect to y from 0 to 1 will look like this. 1, 0. Then, so 2 raised to 2, since 2 is our values above, then all over 2y squared minus 0 raised to 2 all over 2y squared with respect to y from 0 to 1. Then, 2 raised to 2 is equal to 4 all over 2 y squared minus 0 squared is 0 all over 2 y squared d of y with respect to y from 0 to 1. Then, so we can get this 1, 0, then 4 divided by 2 is 2, y squared dy. Note that in the first line above, we wrote the limit as x, our limit is x, is equal to 2, and for our x is equal to 0. X from 0 to 2. So x is equal to 2 and x is equal to 0. So it is unambiguous that x is the variable we just integrated. To finish, we need to compute the integral with respect to y, which is simple. Since x is gone, it's just a regular one variable integral. We calculate that our double integral is 1 or 2y squared with respect to y from 0 to 1. From 0 to 1. So 2y raised to 3 all over 3. From 0 to 1. So 2 times 1 raised to 3 all over 3 minus 2 times 0 raised to 3 all over 3. Which will become 1 raised to 3 is equal to 1 times 2 all over 3. Minus 0 raised to 3 is 0 times 2 all over 3. Is equal to 2 all over 3 minus 0. Which will become 2/3 minus 0 is 2 all over 3. Is it clear? Now, to double check whether our answer is correct or not, we'll be computing using the reverse mathematics. So I'll solve first with the values for our y, or with respect to our y. So to double check our answer, we can compute the integral in the other direction. Integrating first with respect to y, and then with respect to x. The only trick is to remember that when integrating with respect to y, you must think of x as a constant. So our x will become constant. Since for any constant c, the integral of c y squared is c y cubed all over 3. We calculate using this. So, xy squared with respect to y from 0 to 1 and with respect to x from 0 to 2 will become like this. So, x y cubed all over 3, y is equal to 1 and y is equal to 0 below and y is equal to 1 above. With respect to x from 0 to 2. So, x all over 3 with respect to x from 0 to 2 will become x squared all over 6 from 0 to 2 is equal to 4 all over 6. When we reduce 4 all over 6 divided both sides by 2, which will become 2 all over 3, or 2/3. So we derive with the same answer using, or with respect first to x going to y, and with respect to y going to with respect to x. Is it clear? So as it must, this integral gives the same answer. Yay! Now, we are done with solving for the double integral. And what is the main reason why we consider this problem as a double integral? First, it is because that we are looking for the surface area of a rectangle, as well as that it has the limit from with respect to x and with respect to y. Thus, We concluded that this given problem is an example of a double integral. I hope that you have learned something for today regarding calculus with a discussion about the double integral. Goodbye for now, everyone!